Hi everyone! Today we'll be talking about how to find side lengths of similar figures using the idea of scale factors. Here's today's FLT. Given similar triangles, I will be able to find missing side lengths using the idea of scale factors. So before we get into the main part of the lesson, let's quickly go over the idea of corresponding sides. In similar triangles, corresponding sides are always in the same ratio. So for example, let's say we have these two triangles. Triangle ABC is similar to triangle DEF. Remember that squiggly mark tells us that the two triangles are similar. I know that side AB corresponds to side DE. Notice how when we write out the triangle names, so like triangle ABC and triangle DEF, AB lines up in the same spot as DE. That's a good way to check whether or not the sides are corresponding. We also have sides BC and EF as corresponding sides. And lastly, side CA is corresponding to side FD. So we have three pairs of corresponding sides. Sometimes your triangles might be facing different directions, so it might be a little bit harder to see which sides are corresponding to each other. In this example, triangle PQR is similar to triangle XYZ. The side PQ corresponds to the side XY in the second triangle. Again, notice how the letters are lining up in the triangle names. We also have side QR corresponding to side YZ. And lastly, side RP or PR corresponding to side ZX or XZ. Today, we'll be using this idea of corresponding sides along with the idea of scale factors to find the lengths of missing sides. Here's our first example. Please make sure to draw out both triangles in your notes. Here, triangle DEF is similar to triangle GHI. We are asked to find the measure of side HI using the idea of scale factors. So here, I know that these two triangles are similar to each other. We are asked to find the measure of side HI. That's this side right here. Notice how we have a corresponding side, side EF. So these are corresponding sides of each other. And we're also given another pair of corresponding sides right here, side HG and side EZ. So here we're going to be using the idea of scale factors. As we discussed in the previous lesson, to find the scale factor, you put the corresponding side of the second triangle over the corresponding side of the first triangle. So in this case, it's 28 over 7, which simplifies to 4. So our scale factor to go from triangle DEF to GHI is 4. So the size is quadrupling. So let's use this idea to find the length of side HI. We know that it's going to be the side length of EF times the scale factor 4. We know that the side length of EF is 5.8, so 5.8 times 4. The length of side HI equals 23.2. So here we found that the missing side length, HI, is 23.2 by using the idea of scale factors. We know that since the two triangles are similar, if we have to quadruple one of the sides, we have to quadruple the other sides as well to get that similar triangle. Let's look at another example here. Triangle OPQ is similar to triangle RST. Here, we're going to find the measure of side ST using the idea of scale factors. Again, please make sure you're drawing the triangles out in your notes as well. So we're going to find the length of side ST. That's this side right here. And we have the corresponding side in the smaller triangle. the side PQ. We also have another pair of corresponding sides right here, side RS and side OP. So first off, let's find the scale factor. We're going to find the scale factor using the side lengths provided in yellow. So 36.4, again the second corresponding side, over 8, the first corresponding side. If we simplify this, we get a decimal value. 36.4 divided by 8 equals 4.55. So to go from the triangle on the left to the triangle on the right, we use the scale factor 4.55. So we have side ST, that's what we're trying to find. We know that the side length of side ST is the side length of side PQ times our scale factor 4.55. The length of side PQ is 16. So 16 times 4.55. Go ahead and plug this into your calculator and see what you get. So side ST equals 72.8. Similar to the previous example, first we find the scale factor between the two triangles based on given side lengths, and then find the missing side length using the idea of corresponding sides. Let's look at one more example for today. Here, triangle ABC is similar to triangle DEF. Find the measure of side EF using the idea of scale factors. Here, notice how the triangle is not only just dilated, but it's also rotated. So we have similar triangles, but notice how the direction is a little bit different. When you see triangles like this, be especially careful on matching corresponding sides to each other. We're going to find the measure of side EF, this side right here, and notice how EF corresponds to BC. So its corresponding side is side BC. We also have another set of corresponding sides, sides DE and AB. So let's first find the scale factor. The scale factor is going to be the corresponding side of the second triangle, so 4, over the corresponding side of the first triangle, 16. 4 divided by 16 equals 0.25. So our scale factor is 0.25. To find the length of side EF, we simply multiply the length of side BC by the scale factor, 0.25. We know that the length of side BC equals 19.2. So 19.2 times 0.25. Go ahead and plug this into your calculator, see what you get. Side EF equals 4.8. So in this example, we saw that the triangle can sometimes be rotated. So the triangles are still similar, but it's not just a dilated copy, it's also rotated. Also here, notice how the scale factor is less than 1, and notice how the second triangle shrinks compared to the original one. So here's a quick review for today's lesson. In similar triangles, corresponding sides are always in the same ratio. So if you double one side length, you have to double the other side lengths as well. You can use the idea of scale factors to find missing side lengths. The scale factor can be found by putting the corresponding side of the second triangle over the corresponding side of the first triangle. Great work today, and please remember to submit your notes on Canvas.